Hello everyone. In this video, we are going to discuss the continuation of our topic from the last time, and we will be discussing more about expressions. In expressions, these are fundamental means of specifying computations in a programming language. In order for us to understand how to evaluate expressions, we have to um, be familiar with the order of operators and also the operand evaluation. And then from what we have discussed last time, isa sa mga fundamental na type of expressions is arithmetic na expressions. And arithmetic expressions are consisted of operators, operands, parentheses, and then function calls even, okay? And in which the operators can be a unary or a binary or a ternary, meaning we only have one operand for the unary, two operands for the binary, and then three operands for ternary, and there could be even more, right? The purpose of an arithmetic expression is for us to specify an arithmetic na computation. And with the implementation of such computation, so there are some actions that we have to do. Like, for example, we have to fetch the value of the operands. And then we have fetching from the operands, usually from the memory, and executing arithmetic operations on those operands. So what we'll do, or what we did, or what we have discussed last time, is to investigate the common details of arithmetic. So far, we have discussed some of the design issues already, like the operator precedence, operator associativity, and also the operand evaluation. So these are the most common operators for string, let's say for catenation, for Boolean, for character, usually relational operators, for integers, and also for double. Okay, and then one of the practices is we do not use this operator, especially with strings. Rather, we use the equals method. And then for the Boolean operators, we use short circuit evaluation. And also, we do not check doubles for equality. Okay. So assuming that we don't have any precedence and we have this expression a plus b times c, and if we are going to evaluate it from left to right and then from right to left, it could lead to different answers. Okay. So, and in programming, as I have discussed before, we don't want ambiguity. So as much as possible, the results are um, uh, defined or predictable siya. Okay. And well, with that, mathematicians have long ago have designed itong operator na precedence or like hierarchy of evaluation properties, especially if merong mga adjacent operators. So, the operator precedence rules for expression evaluation define the order in which the adjacent operators of different precedence levels are evaluated. And from what we have discussed last time, these are the typical na order of precedence. Okay, so parenthesis, so we have to prioritize this, followed by the unary operators, exponentiation if the language supports it. And in languages like Java or C, we don't have a support for exponentiation. And some arithmetic operations like multiplication, division, modulo, this have higher precedence compared to addition and also subtraction. Okay, and in the unary addition, so we also call this as identity operator because, well, doesn't really do anything. So it has no associated operation and doesn't have any effect on the operand. So like, for example, if you have operand 5, and then if we add a plus before it, unary addition, it's still equal to 5. It doesn't really change anything. And what about the unary na minus? Sa unary minus, in most or languages, it's not really allowed if hindi siya enclosed within a parenthesis. So like for example, here we have a plus na we have a plus operator followed by a minus. And usually that's flagged as an error pag we have an operator followed by another operator. Okay, although in some languages naman it's also allowed. Okay, so in Java, both the unary plus and unary minus implicitly converts a short or byte operand to int. So technically, if meron kang data type that is declared as short or byte, and in order for if it's used in an expression, before siya magamit, i-convert muna siya into an integer. Okay? So, yeah. So we have discussed this last time. And then in which na if we have two operators na let's say negative tapos or like unary minus tapos division operator or unary minus and then multiplication operator, we don't really hindi nagmamatter yung order of precedence dito because the value will still be the same. However, in this example, let's say negative of a raised to b. So, ma-higher yung precedence ni exponentiation compared kay unary. So, we will have to evaluate this first, a raised to b, and then we take the negative of that. So, yes. And then, so this is just an explanation of the previous slide, right? And then, what about for the associativity? So, the associativity comes into play when an expression contains two or more operators with equal precedence. So, for example, we have minus and also plus na operator, these operators have equal precedence. So what do we evaluate first? So usually we evaluate it from left to right. Okay, so it's a left associative, or if you remember in the context of the parsed trees, so the tree is growing on the left side. Okay, and then pag right naman na associative, we are evaluating from the right going to the left. So as you can see, in the assignment na operator, we evaluate d plus 1 first, and then the result start in c, and then c equals to the evaluated na value of plus 1, and so on and so forth. And then you can see the grouping of the parentheses here, in which na we start grouping from the right. Okay? So for the exponentiation operator, most of the languages have the exponentiation operator associating to the right. So it's right na associative. But in ADA, it's non-associative. So meaning, in order for you to enforce ang grouping, or para ma-identify mo kung ng program rather kung ano yung unang evaluate niya, you will have to use a parenthesis for that. And these are the usual na associativity rules in common languages in Ruby. So most of the arithmetic na operators are left associative except exponentiation. For C-based, so most ng mga unary na operators, including yung increment at saka decrement, are right associative, but most ng arithmetic na operations here, like multiplication, binary plus, binary minus, etc., these are left na associative. For ADA, it's all left except the exponentiation operator, which is non-associative. Okay, so how do we alter precedence? Would it be possible? So yes, it's actually possible by placing parentheses in expressions. Okay, so like for example, a plus b times c, we know that without the parentheses, the b times c will be evaluated first. But with the parentheses, we are forcing our program to evaluate a plus b first. Okay, and that is for operator na associativity. We also discussed about operand na evaluation order, and in which na, well, ang ano lang naman dito, ang interesting na part is having the side effects. Okay? And, well, it arises when when the evaluation of an operand matters. So like for example, let's say na meron tayong global variable which is a equals 5 here, and then we have a fun1 na function which changes the value of a to 17, and then it returns a 3. And then in the main, we have this expression a equals a plus fun1. And depending on the evaluation, if we start evaluating from the left, or if we start evaluating from the right, the value of a would vary. Okay, so that's an example of a side effect. So most it happens if we have global na variables, or when a function changes either one of its parameters. Like in this case, we have a global variable 5, and the side effect is that nung kinol mo yung function here, it changes the value of your global variable a. Okay? So, okay. Here, if we evaluate from left to right, so we have a plus fun 1. So a here is equal to 5 since it's from the global na value. And then we call the fun 1. So this will be equal to 8. But if we evaluate from right, so the value of a now is changed into 17 and it being added to fun 1, which returns a 3. So this will be 20. And we don't really want that. Okay, so there are some solutions that we can think of, like disallowing side effects in functions. However, this is not really realistic. Okay, so like for example, if we call fun of a, we don't want that the fun will be modifying a or any global na variable. So however, this reduces the flexibility in the language. And then also there are some cases wherein if we are passing a variable across many functions, it's slower because whenever you call a function, lahat ng mga local na variables doon, or you are making a copy of it, and then repeatedly, let's say if kinol mo yung function 15 times, you have to create a copy of those variables 15 times as well, and we don't really want that. Okay, and what if we define a strict evaluation order? So like for example, we want that the operand on the left is evaluated first, followed by the right. So, however, we can't really enforce that because the compiler itself sometimes reorders the code in order to make it run faster, or it has to go through an optimization process to evaluate whichever operand is cheaper first. So it moves computations around. Okay. So yeah, we have discussed that. And for the next topic, we'll be discussing the overloaded operators. Okay.